Hello everybody, this is Mac here and we're going to work on factoring with what we call a leading coefficient. So what that means is that if you look in front of these x squareds, there's going to be a number in front of that which is going to really change everything. These are a little bit longer, so I only have 10 problems on here. But again, it's a way that they factor out nice and pretty. Now, sometimes they don't. And so when that happens, we have other ways to do this. We have something called completing a square. We have something called quadratic equation. To me, I don't really like doing these. I would just plug them into a quadratic equation and be done. But I haven't taught you that yet, and you may have to learn how to do it this way. So let's just talk about how this is done. First of all, I'm going to write my parentheses right here. But I'm not going to write my x's, because what you have to do, instead of x and x, you have to use factors of whatever's in front of the x squared. Now here it's easy. It's only 2 and 1. Those are my only options. So I'm going to write a 2x and an x, and I'm not going to move them. Okay, now there will be situations where I may have to choose, and so we'll do that when we get there. And on the 3, I've got to choose, ones here, and this really is only 3 and 1, okay? Now, just a couple more things. Third term is positive, which means that something's going to have to add to the middle, and the signs are the same. So everything like that we were doing before still works, but they are just a little bit different. So let me show you what I mean. Third term positive, signs are the same, so I'm still going to write my plus and my plus. Now, here's my question. Does my 3 go here and my 1 go there? Or does my 1 go here and my 3 go there? We don't know, and there's no way to know until you do it. So I'm going to put my 3 there, and I'm going to put my 1 there, but I don't know that this is right. So I'm going to have to check my work. Here's what I do. Remember when we did factors of the third, add to the middle, and we had that? Well, instead of factors of the third, it's going to be factors of the outies. What's 2x times 3? 6x. And the innies, 1x. Okay, so if I take a look at that, and by the way, use the sign too. Positive x and a positive 1, does that add up to a positive 7? It does. Therefore, that, my friends, is the answer. 2x plus 1 and x plus 3. This is only going to make sense after we do a few of them. So let's just keep doing them and see how we feel. Now here, this is lovely. I love that. So it's going to be 3x and x. It can't be anything else. But this one, we have 4 choices now. We could go 1 and 6. We can go 6 and 1. We could go 3 and 2, or we could go 2 and 3, okay? And we don't know. All we know is that third term is positive, so signs will be the same. The signs have to be negative, and my outies, innies will have to add to the negative 11. So I'm just going to look here and just in my brain, 3 times what? Well, 3 times 3 will be 9. And then I'll have a 2 times 1. You know what? I could just look right here and see that that is likely going to be it. But my brain hurts a little bit, so I'm going to check it. What is 3x times negative 3? That's a negative 9. What is negative 2 times x? That's a negative 2. 9x, 2x, right? What's the negative 9 plus negative 2? It's a negative 11. I found my answer. Okay? If you plug in and you found that you got a wrong one, switch them around. All right, now this one is a little nastier because I'm going to look at the 6. This can be either 6 and 1 or it can be 3 and 2. Now, but can it also be 1 and 6 and 2 and 3? The answer is it could, but when you do the leading coefficient, you don't have to flip-flop those. If you just hold them once and flip-flop the third term, you're going to get all the different combinations or permutations or, that you're going to need to make this work. You're going to find every single situation. So hold this one. So let's go. You want to go 6 and 1 or 3 and 2? Let's go 3 and 2. It could be wrong. We don't know that that's right. We're just making a guess. Now this is either 2, 1 or 1 and 2. Okay, so I'm just going to plug one in, not even knowing, I'm just guessing. Now, my third term is negative, so my signs are going to be different. But here's what I really wanted to know. Because the third term is negative, let me zoom in on this. My outies and innies need to subtract to a 1. That's a 1 in front of the x. So will my outies and innies subtract the 1? Well, here I'm going to get a 3x. And here, I'm going to get a 4x. Oh my goodness, I found it on the first shot. 4 and 3 will subtract the 1. But I need it to be a positive 1. So I want my 4 to be positive, and I want my 3 to be negative. Okay? Well, 3x times what flavor of 1 will give me a -3? Boom, a -1. And what flavor of 2 times 2x will give me a +4? A +2. And that, my friends, is how we get it done. All right, let's go on to number 4. Not too bad. I only have one choice for my x value, so it's going to be 2x and x, so I don't have to check this. This can be 10 and 1 or 1 and 10. This can be 5 and 2 or it can be 2 and 5. Now, ultimately, third term is positive. Signs are the same. Take the sign in the middle. And my outies and innies need to add to 9. So now if I want them to add to 9, I know that when I get my outies, innies, both are going to have to be lower than 9, right? So I can already count these out, all right, because I'm going to get something higher than 9. Now, that's great if I want to subtract to a 9, but I want to add, so I want it to be lower. Now, if I put a 5 here, I can tell right now I'm already going to get a 10 with my outies. So even though I've done no math whatsoever, what did I write right here? Even though I've done no math, I'm going to put my 2 here and my 5 there. That just feels right. My outies, I'm going to check. My outies is going to be a -4. My innies is going to be a -5. And lo and behold, they do add to a -9, so I'm done. Okay, let's go to number 5. Yay! I like it when they are prime numbers. You are always a fan of these when they're prime numbers. If they're not prime numbers, I probably wouldn't even solve this way. I would just go straight to the quadratic equation. It's faster. You don't know what a quadratic equation is now, though, so you don't have a choice. But once I teach it to you in the next section, I think you'll agree with me. Now, this one, I'm just going to write 6 and 1 and 3 and 2. We know that they can flip-flop, right? Third term is positive. Signs are the same. Take the sign in the middle, and they need to add the 17. So that means my numbers have to be lower, right, than 17. So I don't want to put a 6 here because I can tell my outies are going to be a 30. Right? So I want to be very careful on that. So let's just try 3 and 2. And I can look, if I put a 3 there, I'll get a 15. And if I get a 2 there, I'll get a 2. That's going to work out because look at this, 15 and 2. Now, some of you, and that will add the 17. Now, you're sitting there going, how did you just see that? Well, because I've done a bunch of them. As you do more, you're going to start to see it too. So just keep practicing, and the more you do it, the more comfortable you're going to feel. Now, I'll purposely put the wrong ones in on a few of them so you can see how this might be some trial and error. Okay, so now this one's a bit of a bummer. Okay, well, I'll go out here. This is going to be 6 and 1, or it can be 3 and 2. Okay, I don't know. Let's start 6 and 1. Okay, 6x and 1x. This is either going to be 3 and 1 or 1 and 3, right? Well, third term is negative, so my signs will be different. Don't write them in yet, okay? But they have to subtract to a 7. So one of my numbers has to be bigger than 7. All right, so, well, the first thing I see, well, I'll put a 3 there. That'll give me an 18. But I can see right here my outies are going to be an 18, and my innies are going to be a 1. Will that ever get me to 7? It won't. So I don't like that. So let me then put my 1 there. Sorry, this is what I just did. My 3 there and my 1 there. And I see that I get a 6 and a 3. Will that ever subtract to 7? No, it won't. Okay, so all of them is wrong. Once I put in all my different combinations, and I know it doesn't work, my problem is that it wasn't 6 and 1. It's going to be a 3 and a 2 if it works. Okay, so now I know I need a number to be bigger than 9. Sorry, bigger than 7. So I'm going to put my 3 there because that'll make my outies 9. And I'll put my 1 there, and that'll make my innies 2. Will 9 and 2 subtract to 7? They sure will. So that's what I mean by the trial and error. But to do it, I need my 9 to be negative, and I need my 2 to be positive. Okay? So 3x times what kind of a 3 will give me a -9? Negative. What kind of a 1 times a 2 will give me a +2? A positive. And that's how we do it. All right, let's go to number 7. So now here, I don't know. What could this be? This could be 4 and 1. It could be 2 and 2. Whenever I see something that's the same number, I always start there, okay? Because it takes out some choice. Now, this can be 15 and 1, or it can be 5 and 3, all right? Or the other way around. But here's the cool part about this. Because these are both 2, you don't have to try the other way. So I'm going to try 5 and 3 just because they seem better for no particular reason. Here I'm going to get a 6, and here I'm going to get a 10. Now, I forgot to do this. Oh, 6 and 10 will become a 4, but wait a minute. Do they need to add or subtract the 4? Third term is negative. They need to subtract the 4. 10 and 4, man, I got it on my first shot. But it's got to be a positive 4. So to do that, I need my 10 to be positive, and I need my 6 to be negative. 2x times what kind of a 3 will give me a negative 6? Negative. What kind of 5 times 2 will give me a positive 10? A positive 5. And that, my friends, is the answer. Let's go on to number 8. Okay, well, this is only going to be 5 and 1. I have no choice. I love prime numbers. Prime numbers with leading coefficients are always good. Now, this can be 27 and 1, or it can be 9 and 3. Do you see anything else? I don't either. Okay, so we're going to leave it there. Third term is positive, so the signs are going to be the same. Take the sign of the middle number. Now I don't have to worry about signs. That's the lovely thing about third term positive, okay? Now, I want my numbers to be lower than 24. So will I ever use the 27? No. Okay, 9 and 3. Now, if I put my 9 here, I know I'm going to get a 45 for my outies. Well, I can't add the 24 if that's the case. So I'm going to put my 9 here, and I'm going to put my 3 there, and I'm going to pray. My outies here is a negative 15. My innies is a negative 9. What's negative 15 plus negative 9? It's negative 24. Yay, I win. Did you see me do some logic before? So that helps me to not always do the trial and error, okay? So use some of that logic. That's actually why we teach you math. Did you know that? But I'm not going to be a math major. I'm not going to do a job that has that. No. But guess what? Math helps you to think logically. And whenever you can think logically in any of life's situation, it doesn't even have to be math, where you say, if this, then what, that's always a good thing. So math just helps you to think logically, which is cool. And then if you learn some math in the process, that's awesome too. All right, so now this can be a 10 and a 1, or it can be a 5 and a 2, right? Third term is negative, so they need to subtract to 1. Now, I don't know what my signs will be, so don't write them in. But I know that I need something to be bigger than 1. Well, they'll all be bigger than 1. But I know my outies and innies need to be next to each other, right? They need to be 7 and 8, or a 13 and a 14. They have to be consecutive numbers, because that's the only way my outies and innies will subtract the 1. Well, if I put a 10 here, I'm going to get a 30. That's probably not going to work. I'm probably going to use my 5s and my 2s. That just feels better. And if I look at it, if I put a 2 here, and if I put a 5 there, I can tell that my outies are going to give me a 6, and my innies are going to give me a 5. Do they subtract a 1? They sure do. But it needs to be a positive. So I need a positive 6 and a negative 5. 3 times what kind of a 2 is positive 6? Positive. What kind of a 5 times x is negative 5? Minus. Boom, 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 boom. There is my answer. Last one. This one, we're going to have choices in both of them. Now, if I have a choice and I have a double number, so here I can go 4 and 1 or 2 and 2. I always start with my 2 and 2. This can be lots of things. It could be 1 and 12. It can be 6 and 2. It can be 4 and 3. And of course, so I have 6 options here. So let's just see. I have 6 options with the 2 and 2. And then I have another 6 options with my 4 and 1. So I can trial and error 12 different times until I get this one right. So let's use some logic before we start, okay? Third term is positive, so signs are the same. Take the sign in the middle. It's going to be minus, minus. So great. Our signs are done. I need them to add. Third term positive, they add the 19. So I can't get my numbers bigger than 19, okay? So if I put a 12 in, with any of these 2s, I'm going to be higher than 19. So these are gone, at least for the 2 and 2s, right? If I put my 6 and 2s in, okay, cool. I'm going to get myself a 4, negative 4, right? And here I'm going to get a negative 12, which doesn't quite get me to 19. So now, should I switch the 6 and 2 to the other ones? No. That's why I picked the 2 and 2, because they're just going to be the same numbers. All right, so I don't have to switch the 6 and 2 in this case. If it was 4 and 1, I would, but at 2 and 2, no, I don't. Now I'm just going to try my 4 and 3. So now 2 times 3, this is going to be a negative 6, and that's going to be a negative 8. They won't add the 19. All right, well, none of them work. So since none of them work, what does that mean? Am I done? Can I do anything else? Come on, erase better, guys. Go away, go away, go away. There we go. Well, what that means is the 2 and 2 was not correct because I couldn't find any answers. So I'm going to use 4 and 1. I don't have to write the 1, it's just X. Okay, now if I can't find a match here, I'm done. Now, can I use 12 and 1? Well, I can't use 12 out here because that'll be bigger than 19, and both numbers need to be smaller than 19. I could do the 12 here, though, but I'm going to get a 12 here, and I would get a 4 here. So, oh, this actually, no, wait, not a 4 there. Sorry, that's a 1. Okay, so here I would get a 4, and here we get a 12, not quite 19. So what I just found out is, go away, go away, go away, go away. They're done. I'm going to try 6 and 2. Now, if I put 6 here, I get a 24, so I don't want that. So it could only work this way. 4 times a negative 2 is a negative 8. Negative 6 and negative, that's not going to give me a negative 19. So I don't like this. All right, there is an erase thing, but this actually works quicker if it works. Now I have 4 and 3. All right, so now does it matter which one? Not really. 4 and 3. What are my outies? 4 and negative, that's a negative 12, and that's a negative 4. No, not quite. So I only have one more option, and that's for me to switch these. And that's for me to put a 4 there and a 3 there. So now the outies are going to be a negative 16. My innies are going to be a negative 3. Oh, look at that. They add the negative 19. I found it. So I purposely made that my last choice because I wanted you guys to see how I would trial and error this. Okay? So that's it, guys. 10 problems. Most people don't love doing these. You don't have to love them. You just have to kind of understand how they work. And now you do. And I'll show you with quadratic equations another way to do these so you don't have to do all the trial and error. But sometimes, like on these first few, they popped out pretty quickly. Okay, so always take a look and see what they look like. And if they get super nasty, quadratic equation. It's all good. All right, well, there's one. There's A. I've got 20 more of these. So let's go to B and we can try a few more.